How's it going, guys? Today we're going to be working on a Leetcode medium question, number 73. It's called Set Matrix Zeros. It's supposed to be a very popular interview question according to Leetcode. And in this video, I'm just going to talk about how I would approach the question step by step until the most optimized solution. So you can read the question description here. I'm just gonna explain it anyways. So we're given a matrix, which is a 2D array, and for every zero that we find, we're going to make the corresponding rows and columns to be zero. So in this example, we have a 0 in the second row and column. So we make that same matrix, the second row and the second column to all be 0. In example 2, we have a 0 and we have two zeros, both on the first row, and one of them to be on the first column, and the fourth, and then the second one on the fourth column. Therefore, we make those rows and columns to be zeros. The most obvious answer to solving this question is not in place. And just to explain what in place is, it's when the space complexity needs to be constant, which means we cannot make any additional memory, right? So if we made some memory, let's say an array that's based off of the number of rows, which is m, or the number of columns, which is n, then that would be additional memory. But variables would be fine, like a boolean or variables such as that. So the most obvious answer people might come up with, which is not in place, and we'll work our way into a solution which is in place algorithm, is we once we're given this 2D array or matrix, we're gonna have two iterations. The first iteration is to find the row and column indexes of where all the zeros reside in the matrix. And then our second iteration, we're going to use the indexes that we found and figure out which cell needs to be 0. Okay. So one simple way to record these rows and column indexes is just to have two arrays, one to record all the row indexes and one to record all the column indexes every single time that we find a 0 in the matrix. Okay. Simple enough. In this case, we will see that the space complexity is not constant because we're making two arrays that depends on the size of the matrix. And in the worst case, we're actually going to have a space complexity of O2mn, which is just OMN, because if the whole matrix is 0, then our row array and column array is going to have n by n size. So let's get started. It would be quite useful to find the row length, to have the row length and column length, so we can use them to loop through it later. We can use them for loops later. For the row length, we're just trying to find the length of the matrix. This is how many arrays we have. For column length, we just need to find the length of an individual array, because that will give us the columns. Okay, simple enough. So going into our first loop, so first we record our zeros, our indexes for where zeros reside into rows and columns. So we need something to actually record to put our indexes in. So we'll just have our row indexes in the array rows, and we have a column indexes in our array columns. So for I in row length, so we're looping through the row length, and then we're looping through the column length, so we're looping through the entire matrix. And if we ever find, if for any of these cells that we're iterating through is equal to 0, we are just going to append it to our rows array with that is I is our current row, and append it to our calls array for the column that we're currently on. Okay. Once we're done that, second we will use the indexes in these arrays to fill in the necessary cells. Okay, so again, looping through the entire matrix, by each row and then each column. So if our current column is in rows, or if our current row is in any of the indexes that we found, or if our current column is in any of the column that we found, then we will simply make the cell to be 0, right? If either of the row index or column index of the cell that we're currently on is in these arrays, which means it has to be 0 according to what they told us. We are not returning anything because we are changing the matrix in place. So let's run it through. So we're going to run code. Rows is not subscriptable, so what is going on here? This is supposed to be a round bracket. We cannot index a function. So this should work as intended. It is not working. Let's figure out what's wrong here. So we make our row length and column length here. We have our rows and columns, and then we say that if it's equal to 0, oh, we didn't make this to be 0. We actually need to make this to be 0. So now it works. So this works, but it's actually very slow and the space complexity is not what they asked us to be. The runtime, the time complexity of this, as you can see, these operations are constant, and we are looping through the matrix twice, so this is just O of n times n. Okay, that's the time complexity. Now let's try to fix the space complexity. Now that we're trying to find to be constant, we will have to remove these two while still being able to record the row and column indexes somewhere. Okay, we have a couple options. We could, let's say, have a bunch of booleans that tells us, hey, this row or this column needs to all be 0 for a second iteration, but that does seem very messy. Another option is to modify the matrix itself. While we're already on a specific row and column, why don't we just make why don't we do something to modify the matrix so that we can attain that information after in our second iteration. In that case, why don't we just do something to the row and column itself? Okay. If we look at all the operations we can execute on an array, we're definitely not going to add a new element or remove a new element. Remove an element. So all we're really left with is modifying and accessing, which are both constant. So we know that. I forgot to mention the constraints here, but we know that each cell is going to be an integer, right? It's going to be at most int max and cannot be any less than int min. So why don't we make some of these or one of these elements to be 0, right? While we're on the current row and column. So we're talking about here. Right here, we want to record ij somehow here. So one may think, okay, what do we change these elements to? So one very obvious option is maybe changing it to be 0, because that's part of the solution. And you could maybe just pick a random row and column element to add in the 0. But the problem with that is that's not very good practice, because we're given an m times n matrix, and that could always be changing. So is there a certain row and column index, or a certain element in the current row and current column that we were currently in, to make it more clean, right, for our second iteration? Well, we're always gonna have a first element of the row and a first element in the column for every element that we're on, right? Even if it's 1 by 1, we're gonna have an element that resides in the first element in the current row that we're on, the first element in the current column that we're on. So if we try to make these to be 0, right, every single time we find a 0. So say we go through this matrix, we find a 0 in the row and column index 1, and we make we modify the first element in the row and column that we're on, so this will be 0, this will be 0. Then we could just, when we're in the second iteration, instead of checking if they're in rows and columns, we check if the first element in the row and column that we're on, if either of those are either of those are 0, then we just make that element to be 0. So that's simple enough. One problem with this algorithm you may notice is for the first column and first row, we're gonna be running into some trouble. There is an overlapping element in the top left corner, because say we find a 0 in the first row or find a 0 in the first column, by this algorithm we're going to make the top left corner 0 twice. In that case, it's actually not distinguishable. However, a very easy fix to that is for one of the row, for the first column or for this first row, we make one of those to be a boolean, right? So if that boolean were to be ever true, we make the entire row to be 0. So if we find a 0 in the first row, let's say, we can flip that boolean on and make the entire row to be 0 later. And for the column, we can use our algorithm where if the top left corner is 0, then we make the entire first column to be 0. So that's just an edge case we're going to have to think about. So let's get started. So we're going to have to be removing these, right? We can't have our indexes. And let's first add the boolean that we talked about. Okay. So let's just call it fill call, right? So do we need to fill our columns? This will ever only be true if we find any 0 in our column. So we have our length, we have our fill column, and then let's start looping through. So we're still going to loop through our rows, and you know what, in every row, right, we're going to check our first column, first element in the first column every time. And if it is equal to 0, if this is ever equal to 0, then we will, then we will flip that to be true, okay? And since we are dealing with the column later on our own, we don't want it to be filling in zeros ourselves. And so if the current cell that we're on is 0, instead of adding it to our rows and columns, we are simply just going to make the first element, so this is the first column, to be 0, first element in the column that we're on to be 0, first element in the row that we're on to be 0. Okay, and then on our second iteration, using this information, In this case, we're actually going to be looping through not the first column and not the first, skipping the first column and row because we're dealing with the column ourselves later, and as the same with the row. So if instead of saying if they're in the rows and columns, we check if matrix I0 is equal to 0, or so if the first element in the row that we're on is 0, or the first element in the column we're on is 0, then we just make that matrix to be 0. Finally, to deal with the edge cases we have, if the fill column is true, all we need to do is we're going to loop through each row because we're filling the first column. Right, each row, and then we make the entire row to be 0, and for the first row, if the matrix 0, 0 is to be 0, right, because that's what we did over here, then we make sure that the entire row is 0. So we're looping through each column, looping through each column, and in each column we are going to make each of those first element to be 0. We want to make first element to be 0. Okay, sounds good. So let's run this. We're probably gonna run into some error here. So it works. Press submit here. Oh, wrong answer. So we did something wrong here. Let's figure out what we did wrong here. So silly me, I forgot to make this to be true. And this, if we run this again, submit it again, we have a wrong answer again. Let's figure out what we did wrong again. So I realized what the mistake was is we had we made our first column to be all zeros, and then we made our row to be zeros. The problem with this is that since we are actually using the top left element for our column to see if our first column needs to be 0, we accidentally made the top left 0 when it's not supposed to be. Sometimes when it's not supposed to be first. So if we filled in our entire first column to be 0, this will accidentally sometimes make the first row to be 0 when it's not supposed to be. If we flipped these around, right, the one that's using the boolean goes after, then that should be fine because this boolean will not be accidentally modified unlike the top left element. So thanks for watching. Hope to see you next time. Hope that helps a lot.